All right, 16b, here's an example of partial fractions where you have to do polynomial division first. So we've got the integral of 2x to the fourth minus 6x squared plus 5x plus 1 divided by x cubed minus 2x squared plus x. And notably, the degree of the polynomial on top of the fraction is larger than the degree of the polynomial on the bottom. And when that's the case, one of the things we usually do is we try polynomial division. So I'm going to do x cubed minus 2x squared plus x divided into 2x to the fourth. Now I notice I don't have an x cubed term, so I write 0x cubed to help keep my places in line, minus 6x squared plus 5x plus 1. And then I say, what do I multiply by x cubed to get 2x to the fourth? 2x, and then multiply that by each of these things. I get 2x to the fourth. 2x times minus 2x squared is minus 4x cubed, and 2x times x is plus 2x squared. Then we subtract. So we'll do this thing where they change all the signs, whatever. This minus this is 0. 0x cubed minus negative 4x cubed is plus 4x cubed. And negative 6x squared minus 2x squared is minus 8x squared. Bring down the next term. When you multiply by x cubed, you get 4x cubed. 4. Also, we know we're going to stop here because we've got the constant term in the quotient. So 4 times this is 4x cubed. 4 times negative 2x squared is negative 8x squared. And 4 times x is 4x. Subtract 0, 0, and 5x minus 4x is x. Bring down the term. And that's my remainder. So I'm going to rewrite this integral as the integral of, well, in fact, I've got it written on the other side. That's going to be 2x plus 4 plus the remainder, x plus 1, divided by this denominator, x cubed minus 2x squared plus x. So that's the reason why we do polynomial division, so we can rewrite the fraction as a quotient plus a remainder divided by the divisor. Now I'm going to actually finish the integral. So here it is again. And I've split it up, so I've done the integral of 2x is x squared, the integral of 4 is 4x, and the integral of x plus 1 over x cubed minus 2x squared plus x, I factored the denominator, where it's x times x minus 1 squared. And now we're going to do a partial fraction decomposition. So I'm going to say that x plus 1 over x times x minus 1 squared is a over x plus b over x minus 1 plus c over x minus 1 squared. Remember, when you have a repeated factor with a higher power, you mean that power and all the lower powers of it, so the first power in this case. And then we're going to multiply both sides by the common denominator. So I'm going to multiply everything by x times x minus 1 squared. That's going to multiply this, and this, and this, and this. When you multiply by the thing on the left, you just get the numerator, x plus 1. And we multiply this times this, the x's cancel, and you're left with a times just x minus 1 squared. When you multiply this times b, the b thing, you get the 1 of the x minus 1's canceling, but you're left with a b times an x times 1 of the x minus 1's. And when you multiply this times c over x minus 1 squared, the x minus 1 squared's cancel, and you get c times x. And then we do the thing where you pick the convenient values of x that make some of these things 0, or pick the places where it would make the denominator 0. So we know we're going to pick x equal to 0 and x equal to 1. Pick x equal to 0, I get 0 plus 1 equal to a times 0 minus 1 squared plus b times 0 is 0 plus c times 0 is 0. You could write b times 0 and c times 0, but they're both 0. So you end up just getting 1 equal to a times 1. So a is equal to 1. For x equal to 1, I get 1 plus 1 on the left. On the right, I get a times 0. I get b times 1 times 0. And I get c times 1. So c equals 2. And then I do this thing called equating coefficients, where I look at the highest power. I mean, you start with the highest power, but you can go lower as well. So I see I have an x squared if I multiply this out. On the left, I have 0x squared. On the right, if I multiply this out, well, this is, let me use a different color here. This is a times x squared minus 2x plus 1. This is b times x squared minus x. And that's c times x. So to the right hand side, I see I would have a times x squared and a b times x squared. so that the coefficients here, 0 and here, have to be the same. So 0 has to equal a plus b, meaning that b has to equal -1, because a was equal to +1. We could have used x, we could have alternatively used x, right? If you want to say, well, I'm going to use x, I've got 1x on the left. On the right, I'd have a times -2x, so I'd have a -2a as a coefficient of x, and I have a -b and a +c. This seems more cumbersome, but you could do it this way and say, okay, well then 1 on the left is -2 times a, which is 1, minus b, which we were trying to solve for, plus c, and the c is equal to 2. The 2 and the -2 cancel, you get negative b equal to 1, so -1 equals b. So either way you do it, you should get the right value for b. Usually I start with the highest power that I see, so I saw I had an x squared here, so I started with that. So here's what this looks like now. This looks like it's equal to, I still have the x squared plus 4x plus the integral of the x plus 1 over x times x minus 1 squared becomes a over x plus b over x minus 1 plus c over x minus 1 squared. So that's going to be a over x, which is 1 over x, plus b over x minus 1, which is -1, so let's just write -1 over x, x minus 1, plus c, which is 2 over x minus 1 squared. And then we're just going to integrate each of these things. That's going to be x squared plus 4x. The integral of 1 over x is the natural log of the absolute value of x, minus the integral of 1 over x minus 1 is the natural log of the absolute value of x minus 1, plus the integral of that one. Let's actually give ourselves a little more space here. It's the integral of 2 times x minus 1 to the -2nd, and I can just write this using the power rule. So my answer here, I'm going to erase this a little bit, just have a little more room. My final answer is going to be all of this, x squared plus 4x plus natural log of the absolute value of x minus natural log of the absolute. Actually, let me show you something here. Instead of writing natural log of x minus natural log of x minus 1, some people would probably write it as the natural log of the absolute value of x divided by x minus 1 plus the integral of this is going to be 2 times x minus 1 to the -1st, right? We're going to add 1 to the power and then divide by the new power. So it's actually going to be 2 times x minus 1 to the -1 divided by -1 plus c. And then I would probably rewrite that and bring that down to the bottom, bring the -1, or 2 divided by -1 is -2, and I would write it as -2 over x minus 1. Or I'll put the minus sign out in front, actually. So that's how you do a problem like that.